Hello, hello. We're going to go over J23, which is adding and subtracting rational expressions. And this video, it should be maybe a little bit of review for you because when we add and subtract rational expressions, it's the same as adding and subtracting fractions. So if the denominators are the same, we just add or subtract the tops and keep it over that same denominator, right? If our denominators are different, then we have to find a common denominator, right, which we call our least common denominator, and we're going to abbreviate that LCD, so that we can write both terms with that same denominator. And then once the denominator is the same, we can just subtract the tops or add the tops or whatever the operation is, and again put it over that common denominator. So what I want to focus on today is making sure we know how to fully factor each denominator, okay? Because here, notice, this denominator has a factor of b and a factor of c. This denominator has a factor of f. We have to be able to see what all the factors are in order to come up with a common denominator, right? So a common denominator has to have the factors of each denominator. So since this has b and c as factors, b and c needs to be within our common denominator, right? Since this one has f as a factor, f also has to be part of this common, our least common denominator, okay? So we're first going to factor everything, and then we just build up each fraction so that it has that least common denominator. So in other words, what we're saying is our least common denominator in this case is BCF. So we want to write both of these with the common denominator BCF. Well, right now, this one just has a BC. It doesn't have an F. So we would have to multiply on top and bottom by an F, right? So now the denominator is BCF. It's what I want it to be. But my numerator now has an A and an F. So that's what's being shown here, okay? Our second term, it only has an F. So if I want to write it as BCF, it needs a B and a C. So again, I would multiply on top and bottom by what its denominator is missing. So now on bottom I have BCF, right, what I was trying to get. But on top now I have A, B, C. So that's where this came from. Oh, I guess that's not an A, I guess that's a D, sorry. DBC. And then once they both are written with the same denominator, then I can go ahead and just, combine the tops, right? All right, so let's look at what that means in terms of rational expressions. When we're dealing with rational expressions, first I need to figure out what all the factors are, right? So before we do anything, I want to fully factor the bottom here and fully factor the bottom here, because once I can see all the factors, then I can figure out what my least common denominator should be. Okay, so let's go ahead and look at this one. I always look for a greatest common factor first, and here I don't have one, right? No greatest common factor because there's no numbers in common, no variables in common. Then I go into whatever factoring method I'm going to use. Here I have 3 terms, so I'm going to use the sum product chart. So here my sum is -3 because that's the middle coefficient, and my product is going to be 2 because I take my first coefficient times my last coefficient. So I need something that multiplies to 2 that I can combine to get -3. The only thing I can multiply to get 2 is 2 and 1, right? And if I want those to combine to a -3, I need them both to be negative, right? So -2 minus 1. Now I did teach y'all a shortcut for factoring, but remember we can only use that if our leading term is a 1, and here it's not. So I'm going to go ahead and just make myself a note that there is no shortcut available here. Womp womp, right? So if there's no shortcut available, what I'm going to do is replace this middle term with the 2 numbers I got in my chart. So I have my 2x squared, and then instead of writing that -3x, I'm going to replace it with the 2 numbers from my chart, -2x, -1x, and then my constant term was a +1. Okay. So now I can do grouping, okay? I'm going to group the first 2 together. Out of the first 2, I can take out a 2x, which is going to leave me with x plus, no, not plus, x minus 1. Okay, remember when we're taking off our greatest common factor, we're dividing it out. So negative 2x divided by 2x is negative 1. Okay, and then over here, I'm also hoping to be left with x minus 1, right? So what I need to take out of these two in order to be left with x minus 1, which really is what I have here, except the signs are flipped, is I need to take out a negative 1, right? And when I divide each of these terms by that negative 1, then I get the signs that I wanted, right? Okay, so now my leftovers match, so I can take out the x minus 1 off of each term, and I'll be left with 2x minus 1, right? So I'm going to go ahead and just rewrite this with a factored denominator. So the numerator is still x squared minus 4x plus 4. And on bottom, we now know this factors into x minus 1 times 2x minus 1. Okay, and I want to do the same thing for the second one. So I have x plus 4, and on bottom, we need to factor it. So again, I look for greatest common factor. In this case, I have one, right? They're both divisible by 2. So I'm going to take that 2 off, and that leaves me with x minus 1. And this is not something I can factor further, right? I have to have at least an x squared to be able to look for a sum or difference of cubes, or an x square, or a difference of squares, right? So if it's just x to the first power, it can't factor any further. So the second denominator is 2 times x minus 1. Okay. All right, so now we are at basically this stage right here. This stage of being able to see the 2 factors from the first term, and in this case, the 2 factors from the second term. So just like my example up here, I need each factor from each denominator to be a part of my least common denominator. Okay, so for this one, my least common denominator, in order for the second term to show up, I need a 2 and I need an x minus 1, right? In order for every factor of this denominator to be within my least common denominator, I need an x minus 1, which I already have, right? And a 2x minus 1. So notice I'm not using 2 copies of x minus 1 because I'm just going off of what each denominator needs. This denominator needs an x minus 1 and a 2x minus 1, and notice I have that. This denominator needs a 2 and an x minus 1, and notice I have that. So I don't need extra copies, okay? No repeats. All right, so this is my least common denominator. So what I want to do now is I want to be able to write each of these terms over that least common denominator, okay? So right now I have x squared minus 4x plus 4, and I have x minus 1 and 2x minus 1. I have x plus 4, and I have 2 times x minus 1. Okay, so all I did is rewrite exactly what I have down here. But what I want to do now is I want to make these denominators look like this. So if I look at this first one, it's missing the 2, okay? So it needs a 2. So just like I did here, whatever the bottom piece needs, that's what I'm going to multiply on top and bottom by. So this one, I'm going to multiply the top by 2, and I'm going to multiply the bottom by 2. Because now notice, my denominator looks exactly how I want it to be, okay? And then I do the same thing to the second term. The second term, it has a 2 and an x minus 1, so it's missing this last quantity. So I want to multiply the bottom by 2x minus 1 so that it looks the way I want it to. But if I multiply the bottom, I also have to multiply the top by 2x minus 1. Okay. So now they both have the same denominators, right? This one has 2 times x minus 1 times 2x minus 1. This one has 2 times x minus 1 times 2x minus 1. The denominators are the same. So notice up here, once the denominators are the same, I can just go ahead and combine the tops using whatever operation is here. So I want to go ahead and combine these tops using the operation that's here, which is a plus. So what that's telling me is I can write this all over 2 times x minus 1 times 2x minus 1. Right? I don't have to write it as 2 separate fractions anymore because they have the same denominator. So I can combine the tops. Okay. Now, in order to combine the tops, they can't be being multiplied, right? I need to FOIL all this out. So I'm going to go ahead and distribute this 2 in. So 2 times x squared gives me 2x squared. 2 times negative 4x is negative 8x. 2 times positive 4 is positive 8. And then I'm adding, right, because that was my sign in the middle, I'm adding whatever this ends up being. So in order to multiply this out, I need to FOIL or distribute using over, under, or whatever your factoring method is, right? So I'm going to go ahead and start. X times 2x is 2x squared. X times negative 1 is negative 1x. 4 times 2x is 8x. And 4 times negative 1 is negative 4. Okay? So now I have it all multiplied out. So all we've done is we've taken the denominators we had and factored them, figured out what our common denominator is, then we've multiplied on top and bottom to make our denominators look the way we want, and now that they have the same denominator, we combine the tops. Okay, so this is the top now, I just need to go ahead and combine it, right? So combining like terms. So I have 2x squared and 2x squared, right? Which gives me 4x squared. And then my x terms, I see a negative 8x and a positive 8x, so those just cancel. Oh, and then I still have another x, right? So negative x. And then my constant terms, I have a plus 8 and a minus 4. So that combines to a positive 4. All over my least common denominator, which is 2 times x minus 1 times 2x minus 1. Okay. All right. We're almost done. So this was our whole purpose was to take two terms and combine them into one term, right? Now we need to see if that one term will simplify. And the only way that this would simplify is if I can factor the top. So I'm going to go ahead and check to see if this will factor. Because if it will factor, maybe I can cancel one of these factors on the bottom, right? If it can't factor, then I'm done. So I look for a greatest common factor, and in this case there's no numbers in common, no x's in common, so we're going to say no. And then we do our sum product. Our sum is our middle coefficient, which in this case is a -1, and our product is our first coefficient times our last, which gives us a 16. So we're looking for numbers that multiply to give us 16 that can combine to a -1. Right? So let's see, we have 4 and 4, we have 8 and 2, and we have 16 and 1. So all the number pairings I can use to get 16, none of them can be combined to get a -1, right? So nope, not factorable. And if it's not factorable, then I can't hope to cancel anything. So that means that my answer just stays like this. Okay? So again, factor each denominator completely. Once we have each denominator completely factored, we can figure out what our common denominator would be. And then we just write each of the terms with that common denominator by multiplying on top and bottom by what its current denominator is missing. Right? Once they have the same denominators, then we can go ahead and combine across the top. And then the last thing we do is see if we can simplify the top by factoring. Okay, let's look at another one. Let's look at this one. So this one is a subtraction. Same thing. We want to factor both denominators first so that I can write this fully factored. So I'm going to have x over something factored minus 5 over something factored, right? So to factor these, I first want to look and see, do I have a greatest common factor? This first one, I don't, right? No numbers in common, no variables in common. So I go to my sum product chart. My sum is my middle coefficient, which is 11, and my product is my first coefficient, which is a 1, times my last coefficient, which is a 30. So 1 times 30 is 30. So I need a product of two numbers that combine, or sorry, that multiply to give me 30, that combine to give me 11, which would be positive 5 and positive 6, or in other words, 5 plus 6, right? And on this one, we can use the shortcut because our leading coefficient is a 1. Yay! So remember, our shortcut states that the numbers in our factored quantities are the same as the numbers we came up with in the chart, right? All right, so I have the first denominator factored, and now I need to factor the second denominator. So again, I'm looking for a greatest common factor. In this case, I don't have one, no numbers in common, no x's in common, so we're gonna say no. And then I look for my sum, which is 9, and my product, which is my leading coefficient, which is a 1, times my last coefficient, which is a 20. So 1 times 20 is 20. Two numbers that multiply to 20 that combine to 9 would be 4 and 5. Positive 4, positive 5. And again, we can use the shortcut because our leading coefficient is a 1. So if I got 4 and 5 in my chart, that means this is going to factor into x plus 4 and x plus 5. X plus 4 and x plus 5. Okay. So looking at what we've come up with, now this denominator is perfectly factored. This one's perfectly factored. I need to come up with a common denominator, right? So our least common denominator for this term, or sorry, for this denominator, I would need an x plus 5 and also an x plus 6, right? For the second denominator, I would need an x plus 4, which I don't have, right? And an x plus 5, which I already have. So this is going to be my common denominator. So I want to write both of these terms with this denominator, okay? So I'm just going to go ahead and write both of them as they are. So right now I have an x on top, and I have an x plus 5 and an x plus 6. This one I have a 5 on top, and I have an x plus 4 and an x plus 5. So I'm looking to see what this first one is missing. What is x plus 5 and x plus 6 missing in order to look like this? Well, it's missing the x plus 4. So that's what I'm going to multiply by on top and bottom. Okay, so now the denominator looks the way I want it to. It looks like my least common denominator, right? And my top has changed a little bit. Then I want to look at the second term. The second term has the x plus 4 and the x plus 5, but it's missing the x plus 6. So x plus 6 is what I'm going to multiply by on top and bottom. Okay. Now their denominators are the same. Once their denominators are the same, I can write the whole thing over that same denominator. Okay. So I'm just going to write the numerator from this one, which I'm going to go ahead and distribute this x. So I get x squared plus 4x, and then I'm subtracting. Now notice, whenever you're subtracting, that means you're going to minus everything that is in this numerator. So if there's more than one term there, be sure you use parentheses. Okay. So when I distribute this 5, I get 5x plus 30. And then I'm going to go ahead and distribute this negative since I was subtracting. So this gives me x squared plus 4x minus 5x minus 30 all over my least common denominator. Okay, and then notice I have common terms. I can combine my 4 and my negative 5x. So this gives me x squared minus 1x minus 30 all over x plus 5 times x plus 6 times x plus 4. Okay, so now we have it all combined down into one term. So now that we have our one term, the last thing we have to check for is to see if that term will factor, because if it will, maybe we can cancel out one or more of these factors on the bottom, If it doesn't, then we just stop here. Okay, so let's go ahead and see if this guy factors. Greatest common factor. There's no numbers in common, there's no x's in common, so we're going to say no. And then we're going to look at sum product. Our sum here is a -1, that's our middle coefficient, right? And our product is our first coefficient, which is a 1, right? Times our last number, which is a -30. So 1 times -30 is -30. And I should be able to find a pair of numbers that multiplies to give me -30 that combines to -1, right? That would be -6 and +5, or -6 plus 5. And because my leading coefficient is a 1, I can go ahead and use the shortcut. Yay, shortcut! Which means that this factors into x minus 6 and x plus 5. So I'm just going to rewrite this with the numerator factored. We just determined that the top is the same as x minus 6 times x plus 5. And on bottom we have x plus 5 times x plus 6 times x plus 4. So you can see here that our x plus 5s will cancel, right? Which leaves us with an x minus 6 on top and an x plus 6 times x plus 4 on bottom. Since there's nothing else on top with that x minus 6, we can go ahead and drop the parentheses, right? And when you enter your answer into MyMathLab, you do not need to multiply out the denominator. You can just leave it in factored form, okay? So quick recap here. Okay, when you start off, factor each denominator completely. Do not use the shortcut unless your leading coefficient is a 1. Okay, if your leading coefficient is anything other than 1, you have to take the numbers from your chart, replace the middle term, and group. Okay. All right. So once we get both denominators completely factored, we figure out what our common denominator should be, and then we work to build up those denominators so that it looks like that common denominator. Once both both fractions have the same denominator, then we can combine the numerators and put it over that same denominator. And then from there, we're just simplifying the top and seeing if it factors. Okay? All right, so there are 3 for y'all to try. So go ahead and pause the video and try those 3. If you get stuck, or whenever you're ready to be checked, go ahead and unpause the video and we'll go over them. All right, so let's go ahead and go over the first one. The first one, the denominator is a difference of squares. So my base being squared to get a squared is a, my base being squared to get 1 is 1. So I know difference of squares factors into the first base plus the second and the first base minus the second. So I can rewrite that term as a squared plus 1 over a plus 1, a minus 1, right? Now, the second denominator doesn't factor at all, right? It is just what it is. So looking between this denominator and my second denominator, I can tell that my least common denominator needs to be a plus 1, a minus 1, right? This is what my least common denominator is. So if I want to write both terms with that denominator, the first one already has that denominator. I don't have to do anything to it. But the second one, it only has the a plus 1. It doesn't have the a minus 1. So a minus 1 is what I'm going to multiply by on top and bottom of that second fraction so that its denominator matches what I want it to look like in that common denominator. Okay. Now that both denominators are the same, I can go ahead and just subtract across. Excuse me. So the first numerator stays the same, and then I'm subtracting this second numerator. Now I went ahead and multiplied this out. So like a times a gives me my a squared, a times -1 gives me my negative a, -1 times a gives me my negative a, and -1 times -1 gives me my positive 1. And since I am subtracting, that means I need to distribute this subtraction to every term of that second numerator. Okay, so that's going to flip all the signs. Once I do that, my a squared terms and my 1's cancel. and I'm just left with a plus a, which means that I have 2a as my new numerator all over a plus 1, a minus 1. And 2a is just a monomial. It's nothing that we can factor, so that is our final answer for that one. Okay, let's look at number 2, which I had to write in because mine is silly. Okay, so number 2 is 9x plus 2 over 3x squared minus 2x minus 8 plus 7 over 3x squared plus x minus 4. Now, both of these denominators have a leading coefficient that is not 1. So you cannot use the shortcut on either of these. Okay. On the first one, our sum is going to be -2, and our product is our first times our last. So 3 times -8 is -24. So I can use -6 and -4 to multiply to get -24 and combine to get -2. Okay, there's no shortcut, so I have to replace the middle term and do grouping. Okay, when I finish out that factoring, the first term can be written as x minus 2 and 3x plus 4. Okay, so this is the denominator of this first term. Second term, same thing. Middle coefficient is a 1. My product is my first times my last. So 3 times -4 gives me a -12. Multiply it to a -12, combine to a +1. My pairing would be 4 and -3. Again, no shortcut because my leading coefficient is 3. So I take that 4 and -3 and replace the middle term so that I can group. Once I do that, fully factored, I should get 3x plus 4 and x minus 1. If I'm going fast, feel free to pause the video so that you can catch up. Okay. All right. So here's my 2 denominators. So looking at my 2 denominators, I need to come up with a least common denominator. And I know it's going to need an x minus 2 and a 3x plus 4. So I write those down. And then this one needs a 3x plus 4, which I already have, and also an x minus 1. So I need to tack on the x minus 1 factor. Okay, so these are the 3 quantities that I want to be in the denominator of these 2 terms. So the first one, I already have the x minus 2 and the 3x plus 4, but I'm missing the x minus 1. So I need to multiply on top and bottom by x minus 1. Now the denominator looks the way I wanted, and on top I have the 9x plus 2 that was already there times the x plus 1 I need from the bottom, right? On the second one, I already have the x minus 2, or I'm sorry, I already have the 3x plus 4 and the x minus 1, but I need the x minus 2, right? That's the one I'm missing in the second denominator. So that's what I'm going to multiply by on top and bottom. So now the 2 denominators match, right? They have the least common denominator. So once the denominators are the same, I can write it as one fraction by just multiplying out the tops and adding them, okay? So when I multiply out this piece, FOIL it, distribute it, whatever your method is, I should get 9x squared minus 9x plus 2x minus 2. And then I'm adding that to what I get when I distribute this out, which is 7x minus 14. Okay? All my x terms, when I combine them, they combine to 0. So they cancel out, and I'm left with 9x squared, and then a -2 and a -14, which combine to -16. So if this top piece doesn't factor, then I stop, and this whole mess is my solution. Okay? But what I notice is that this top piece is actually a difference of squares, right? 9x squared is a perfect square. My base would be 3x. And 16 is a perfect square. My base would be 4. And a difference of squares factors into my first base plus my second, and my first base minus my second. So I can rewrite the numerator as 3x plus 4 times 3x minus 4. Okay? And then that will allow me to reduce the 3x plus 4 factor on top and bottom. Okay. All right. So let's go ahead and look at the last one, number 3, which hopefully is a little bit easier than number 2 was. So number 3, we only had to factor one denominator, and we were able to use the shortcut. Yay! So the first denominator, to get a product of negative 20 and a sum of negative 1, we're going to use negative 5 and 4. So this is the denominator of the first term. Denominator of the second term, it doesn't factor, so it's just y plus 4. So looking at these two denominators, it's pretty easy to see that my least common denominator is just going to be y minus 5 and y plus 4, because that's what this one needs. And then notice the second denominator is already included. So I'm going to write each of these denominators like this. The first one already looks the way I want it, so the top of it's going to stay the same. I don't have to multiply by anything to make it look like that. It already looks like that, right? The second term, I only have the y plus 4 factor, so I need the y minus 5 factor. So if I'm going to multiply by y minus 5 on bottom, I have to multiply by y minus 5 on top. Okay. And now that the denominators are the same, I can go ahead and combine the tops using the operation shown, which is subtraction. So I'm going to write this as y minus what's on top here. So that's what I did here. Y minus what's on top of the second term all over that common denominator. Then I just need to distribute the negative 2, which gives me y minus 2y plus 10. And then notice y and negative 2y, neither of these are squared terms, right? These are just regular y terms, so we can go ahead and combine them. 1y minus 2y leaves me with negative y plus 10 over my least common denominator. And this one doesn't factor, right? On top, the only thing I could do is take out a negative 1, and that doesn't help me, because even if I take out a negative 1, it's not going to cancel with any factors in the denominator. So I'm just going to leave it like this. Okay. All right. So that is the end of J23, which is adding and subtracting rational expressions. So you should now be able to complete that one in your My Math Lab assignments. If you have any questions, please let me know.